Hello, programmers! A big, giant welcome to More About Java Loops. Topics in this discussion include a review of the while, the do while, and the for loops, counting loops, Sentinel value control loops, nested loops. The while loop has its test condition at the top of the loop. It is possible that the body of the loop will not be executed if the test condition evaluates to a false. The do while loop has the test condition at the bottom of the loop. The body of the loop is guaranteed to execute at least one time. Both of these examples are counting loops. The number of times through the loop is determined before the loop even starts. The for loop is just a fancy while loop. Although the initialization, loop control, and increment are all placed in the for statement, these three pieces of code are executed at different times. The initialization occurs before the loop even starts. The test is done at the top before the body of the loop. The increment happens after everything in the body is executed. Here is a comparison between the for loop and the while loop when used to go through the loop a specified number of times. The variable I is declared as an integer. I is initialized to 1 before the loop even starts. The first thing that happens in the loop is the test to see if the body of the loop is to be executed. If the test evaluates to true, then the body is executed. The last thing inside the loop is the increment, I++. In a counter-controlled loop, the decision of whether to loop or not is based on a count that is applied before the loop even starts. In a Sentinel value-controlled loop, the decision of whether to loop or not is determined by the data input from the user from within the loop. A nested loop is a second loop that occurs within the body of the first loop. Here are two examples of counter-controlled loops. 1. Find the average temperature of 5 cities. 2. Display a trigonometry table for sine, cosine, and tangent from 0 to 90 degrees in 3-degree increments. This program reads temperatures from 5 cities and then computes and displays the average temperature. In this example, the count of the number of cities is defined with a constant at the top of the program. Public, static, final, int, city count equal 5, semicolon. Instead of using a constant, the program could have also asked the user how many cities there were in the list. Read that value from the keyboard and then use it as the count. In either case, the number of times through the loop is known at the start of the loop. That is why it is called a counting loop. Here is another example of a counting loop. The program displays the trig tables for sine, cosine, and tangent from 0 to 90 degrees in increments of 3 degrees. Look at the increment within the for loop statement. It has degrees plus equal 3. Any valid C or C++ statement can be used within the 3 parts of the for loop: initialization, test, and increment. Just make sure that the test condition evaluates to true or false, and make sure it will eventually evaluate to a false to cause the loop to end. One thing to remember is that radians are typically used for trig functions in computer programs. There are 2 pi radians that make up a full circle, just as there are 360 degrees in a full circle. To convert degrees to radians, multiply by 0.017453292576923690768489. That number is too hard to remember. It's easier to take the ratio of degrees to 360 and multiply it by 2 pi. Java has a constant already defined for pi. It is math.pi. Once the degrees have been converted to radians, use Java's math functions to find the values for sine, cosine, and tangent. The functions are called sin, cos, and tan. Display these values on the screen. Since the tangent of 90 degrees approaches infinity, the value for the tangent at 90 degrees is not displayed. Remember the definition of a Sentinel value-controlled loop. With a Sentinel value-controlled loop, the decision of whether to loop or not to loop is determined by data input from the user from within the loop. Here is an example of using a Sentinel value-controlled loop. Find the average temperature of several cities. Enter the value 999 when done. One of the most important things to consider when creating the code for a Sentinel value-controlled loop is to make sure that the stop value that the user needs to input is both a legal value for the data type and a value that would not be used as valid input. 0 and -1 are not a good choice when inputting temperatures because it is possible to get values less than 0. Once you see many programs, you will often see 999 or 9999 used to end a list of data values. Once we start working with data on a disk, we can use the end of file to indicate that we have reached the end of data. The Sentinel value-controlled loop reads the first value before the loop even starts. Once inside the loop, that value is processed and any additional processing takes place. Although it may look weird, the next value is read at the bottom of the loop and the loop counter is incremented. Here is a flowchart for a Sentinel value-controlled loop. During the initialization, the loop counter is set to 0 and any other required variables are declared and initialized as needed. The first value is read, including a prompt message if needed. It is important that the data value be read before deciding on whether to do the body of the loop. This is the reason that the input is not done at the top of the loop. Maybe there's no data to be processed and the loop ends right away. The other thing to consider is that when the stop value is read, the loop needs to end without processing it. If we read the input value at the top of the loop and always process that value before deciding whether or not to end the loop, in the example of using 999 as the stop value, the 999 would be considered as one of the temperatures, and we would count this as one of the cities before ending the loop. Our average would definitely be thrown off by a huge amount. We also want to end the loop if 999 is entered as the first value to indicate that there was no data. Here is the code and a sample output. The city count is initialized to 0 and the first temperature is read before the loop starts. The while statement decides whether or not a 999 was entered. If not, then the body of the loop is executed. We will add the input temperature to the total in the body of the loop. At the end of the body, we read another temperature and increment the city count. We need the city count when determining the average temperature. After the loop ends, we can compute the average and display the city count and the average temperature. A nested loop has one loop inside another loop. Displaying a multiplication table is a great example for nested loops. The outer loop is used for each line. Another loop is used within the body of the first loop to display a column of numbers. At the end of each line, the cursor is moved down to the next line and another column is displayed. Use good names for variables such as row and col to indicate the row or line or column for each value that will be displayed. This program uses constants at the top of the program to define the number of rows and columns that will be displayed. The program could easily be modified to input these numbers from the user's keyboard instead of using constants. It is important to know what the largest value that will be displayed so that the columns can be lined up together. A field width of 4 will give room for a space character and 3 digits for each value being displayed. That is why the printf statement has the open parentheses, quote, %4d, quote, comma, row times column, close parentheses. There is also a title at the top of the multiplication table that is centered above the table. To center the title above the table, we need to know the width of the table and the width of the title. The width of the table is the number of columns times 4 because there are 4 positions on the screen used for each number and its spaces. The width of the title can be determined by the length of the string, title.length, open close parentheses. The width of the table divided by 2 would start the title at the midpoint position of the table. We want the title centered. This can be done by subtracting the width of the title divided by 2. Since both values are divided by 2, it is just as easy to do open parentheses column count times 4 minus title length open close parentheses divided by 2. Loops are very powerful. The more you use them, the better you will become. You will find loops in almost every program except the tiniest of them all. Bye-bye.